to do just 2 tests in the final. Okay. Uh,
Okay, wait, hold on. I have a question.
so we're supposed to have 3 tests in the final. Um, but it appears that we might have to just do 2 tests in final. That's what I'm thinking right now. I mean, I don't know how. Okay, I mean, we could take test 2 and just see how it goes. I mean, um, 18 months? That's a flood, man.
Fake news.
Yeah, if this is going on for 18 months, I'm taking a semester off.
Hey Siri, is this going on for 18 months?
Anyway.
Oh, don't be an idiot.
Okay, so
All right, hold on. I have a question.
yeah.
You say homework plus classwork is 25%.
Yeah, so of course this time we have now what? Homework and oh, why am I writing using this?
Yeah, the homework was 10%, and I decided to take the L by not buying it.
What? I'm so who's talking
So,
right now?
so is
talking
the
nonsense?
percentage going?
You decided not to do homework?
Yeah, I didn't want to pay 100.
But what about all the lunches?
What do you mean?
Yeah, that's a lot of lunches, man.
Yeah, but that's necessary for my survival.
Why didn't you just do it all in 2 weeks with a free trial?
Oh no, I mean I did some of it. I did like 5 homeworks in the first 2 weeks. Didn't get a 0.
Oh, just so you know that's what the UK and our universities are saying.
Why are you
18
still
months.
talking about Corona? All right, can we
Thanks,
talk
Siri.
about math?
Anyway, we have homework and quizzes. Okay, then I can make the homework and quizzes.
15%?
Yeah, I mean the homework 10%, classwork and quizzes 15%. Maybe I can do that.
Good, good.
Is the
And
quiz from today gonna?
And then extra credit on top of that?
What extra credit?
What extra
You said there was extra credit.
The quizzes
So
we took.
the one that you guys took on Friday, that's definitely extra credit.
The one
I'm
in class.
deciding on the one that's due next Monday, because that's everyone should take it. So yes.
Just
So
make the
maybe,
homework 25%.
let's make it homework 10%.
Do you drop any classwork?
Mm-hmm.
Yeah.
Do you
But
drop
yeah, so
do you
let's make
drop
this
the
whole
homework
thing,
rate?
25%, okay? And I'll try to keep homework I try to keep homework as close as to 10%. Okay. All right. So this is what I'm thinking right now. I mean, if test 2 goes really well, there's no hiccups, then maybe you can try test 3. But I'm not too positive. I'm not too hopeful about this whole online testing. Okay. Any questions, guys? Anyone?
How much is the extra credit gonna represent?
Oh, it'll be just like regular classwork, not just one. Yeah.
For the test, how many questions would you have?
I don't know. I haven't made it yet.
When's
But
test
but
2?
remember, for tests are 50 minute per session, so I can't ask you too many questions.
Do we take it like the time, like during class time, or is it?
Yes, has to be. So that's why you need to know all the ins and outs of the platform. Okay. But how long did it take you to get ready to take the quiz today?
Like 3 minutes.
3 minutes. So all that taking the pictures of the surrounding, all that only took 3 minutes.
Well, maybe 5.
5 minutes. Okay.
We shoot for 10, 15. We don't know.
Took you 15 minutes.
Yeah, I gotta get the whole layout of the room. It's a big room.
Yeah.
Well, take it in a smaller room then.
I can try taking it outside. That's a bit smaller.
So you want to take it in the bathroom? Okay.
Problem solved.
When is test 2 gonna be?
Yeah, it's not gonna be this next week. Yeah,
So
we
when?
don't have time to get ready.
Nick, when you
So
gonna make that review sheet?
Expect there will be quizzes like every class period. I mean, not like during the class period, but then maybe before. I don't know. Maybe during the class period. We'll see. And then yeah, because I want everyone to be on board with this lockdown browser thing. Okay. Okay, so let's this is I'm not saying this is not final, but this is what I'm thinking right now. Okay. So just to guys to give you guys heads up. All right.
Are we still doing classwork?
Huh?
Are we still doing classwork?
I mean, probably not. I mean, how can we do it? I mean, can we do it? I mean,
Individual.
You can
Huh?
show us at the end of class, and then we just send you a picture on D2L.
Yeah, like a
Just have a
PDF
submission
or something.
folder.
but how do you discuss with each other?
We don't.
Are you saying quizzes are gonna take place in classwork?
Yeah, most likely. That's what I'm.
Oh,
That's what
okay.
I'm thinking right now. So
Sounds good.
Okay,
maybe,
yeah.
maybe I'll do that in place of.
And
I
quizzes,
don't know.
quiz is
Yeah,
gonna be like
I
on
don't know yet.
lockdown.
It's very unsettling time. Okie doke. So yep. Okay, for those who are here in this room, did you all take were you all able to take the quiz today?
Not yet.
Not yet.
Not yet.
Has anyone tried but failed?
I did, and it was fine.
It
I
was
took
fine.
it. It was easy.
I didn't understand the last question.
You didn't understand the last question? Okay. Could you keep it to yourself since people are still taking it?
Yeah.
Okay. Jesus says your webcam wouldn't work. Well, get it to work, okay? I mean, I won't be able to help you with that because I'm not a very technical person, but okay. Yeah, so try you might have to you might have to close all the background apps, okay? Or like yeah, something like that, okay?
And
We had some
UICF is
people on-
also still working right now.
Yeah. I mean, it's not due until next Monday, like before 11 or 11 something. Yeah, Tyler, the quiz is on D2L. So you are doing this on D2L, just that you're doing it with the webcam on. And remember, I don't care about doing quizzes without the webcam, but we're only doing this to get ready for the test. That's the whole reason. Okay. Okay. All right. Any other questions, concern?
So the wait for homework is not being increased.
That was my plan, but since Sebastian decided to spend money on food instead of
I mean, you can do like higher weight for them and just lower weight for me.
Yeah, I made a few decisions on
like priorities at some point. So if we
Yeah.
could keep the homework
Okay.
weight the same, that'd be cool.
Okay. So what about Andrew? Andrew, that was you, right?
Yeah.
Did you not do the homework either?
Well, I've been doing the homework, but like some of them I haven't done because I had more important.
So you've done some of them, okay?
Yeah, most of it. Yeah.
Okay. I mean, I'm gonna drop couples to
Damn.
in the end. So yeah,
I did the first
if you
5.
then that should be fine. Yes.
Can
Sorry.
you drop? Can you drop like the rest
Wait,
of
like
them?
our
Can I
lowest?
get 100?
I didn't do the homework.
No. Usually what I do is I drop. Let's say the homework total is out of 300 points. Okay. Then I just I don't know. I could just have it out of 260 or something like that.
250.
Okay,
150.
300 was a hypothetical number, so yeah.
Okay.
Yeah, so something like that. So yeah. Yeah. Okay, so when you say people, you mean you, right? No. Yeah. Okay. Ah. And also, yeah. Please don't make me remind you of my political affiliation, okay? All right, so okay, I think that was enough time for Paul. Can we use notes on the quizzes? No. So this is supposed to be a um, close note, close everything, okay? So yeah. Yep. Okay, then let's finish 4.4. By the way, did you guys find, yeah, most of the questions will be multiple choice here, so that's not an issue. Some short answers, some fill in the blanks, that kind of questions. I mean, you'll see it, I mean, if you take the quiz 00. All right, so did you guys all, how do you think of the lecture from last time, like the beginning of 4.4? Did you guys find it easy?
Yeah.
It was fine? Because, I mean, I don't want to scare you, but the contents are getting very technical and theoretical from now on.
As
So,
long as we got Nick.
Oh, I don't
Oh,
like
yeah.
that.
yeah. Yeah. Okay, so yeah, it's unfortunate that we don't meet in person anymore, because we need that. But so you know, I just want to remind you that, I mean, I've taught online classes before, and online classes are like 10 times more difficult than regular classes, because it requires more work, effort, and determination on your part than regular classes. Okay, just remember that. All right. So here's some generalization. So we have this is a vector space. We have a basis, and this is the basis vector. Then x is going to be, so you write a given vector x, okay? So x is in V using the given basis. Okay, and suppose that you have this unique, remember we talked about it, right? These are the ways, okay, or coordinate vector. So you can write this as then this vector times that. You see that because it's nothing more than C1 times this plus C2 times that, this times this. Okay, so again, X is just a random vector in V, the vector space. You write X in terms of the given basis, so B1, B2 up to Bn, and it's a linear combination of those using these ways. C1, C2, Cn are coefficients of the weights. And you can rewrite this as a product of these two vectors. Actually, it's a matrix, but okay. And this is PB, which is this. And this is the coordinate vector. Okay. So then all of this, what this is telling you is X is PB times the coordinate vector relative to beta. Then remember, PB is the matrix consisting of what? Basis, right? Basis vector, which means they are, what was the first condition of a basis?
Must be linear independent.
Linearly independent, which means this is invertible. Okay. Yes. Because you have pivots in every row, so you can do that. That means, what is X? The coordinate vector X beta. If PB is invertible, then maybe I can multiply on both sides, on the left side of both sides, by what?
The inverse of PB.
Yes, I can multiply both sides, the left side of the both sides, by PB inverse. Then this times that will give you identity, which means that's just 1. Then XB is going to be what? PB inverse times X. The PB is something simple like 2 by 2 matrix. You can find its inverse matrix easily. You just multiply that by the given vector. Then you get the coordinate vector. Okay. So this is so much easier than what we did before. I mean, it's not easier, but it's just quicker, I guess. Okay, so remember this formula, and so you're given a vector X, which is in R2, and this is supposedly a basis of R2. Yeah. I mean, we could have used 1, 0, 0, 1, but where's the fun in that? The first question is can this be a basis? So we have 2 vectors, so these have to be linearly independent. Then you're done. Are they? 1, -4. 1, 2. Can I make this 0?
Yes.
So 4. Yes. I'm sorry. How can we make this 0?
Times row 1 by 4, and add that to row 2, and then it gives you row 2.
Yeah, I can do this, right? No. Yes. So 0, 4 times that is 8 by. Yeah.
Yep.
So
And then divide row 2 by 5.
what?
Divide row 2 by 5, and you get 1 in the bottom right.
That's supposed to be.
R2 divided by 5 equals R2, so we have it to be a 1, 1.
You just need pivots to prove it's linear.
I'm confused. Did I make a mistake here?
No, you didn't.
Okay. All right. So the point is they're linearly independent because we have a pivot here, pivot there. Okay. Okay. So it's a basis. So then the span of this, of course, will be the whole R2. So yes, it's a basis. Okay. And how do we find this? So last time, if you remember, yesterday, I'm sorry, Wednesday, how do we find the coordinate vector? X of beta given x, but this is nothing more than like C1, C2, such that x is C1, let's call this B1, B2, B1 plus C2, B2. So to find C1 and C2, which are the elements of x beta, we do something like this, B1, B2, x, right? And then we reduce this to 1, 0, 0, 1, something, something, and this was C1, this was C2, correct? Remember doing this on Wednesday?
Mm-hmm.
Good, 1 person, 2, okay, I'll take that. So we could do that, and okay, if you don't remember this, then please go back and review. But we can just use this formula, okay? So what is, okay, so I need PB inverse. What is PB in this case? PB is simply the matrix consisting of the B1 and B2. So that would be 1, -4, 2, -3. Then if you took the quiz today, you know how to do this, right? So this is 2 by 2. So you could either, if you reduce this to I something, okay, or because it's 2 by 2, you do the following: 1 over, what is it? Determinant. This time
AD minus BC.
So what is that? -3 plus 8. That's 5.
Yep.
And then what do? You flip these two and put negative signs, right?
Yeah.
-2, 4. My goodness. Okay, I'll just leave it like that. I'm not going to multiply everything here by 1/5 because what I want is, so this is my PV inverse. I need to multiply that by x, okay? So I'll do that first. So then PB inverse times x, which is 1/5. And then x, what is x? This, okay? Okay, so yeah, what is this? 1/5 times, this is 2 by 2, 2 by 1. The answer should be 2 by 1 vector. So -3, no. Who's my algebra person?
Should be row by column.
Yeah, 3 plus 12 to 15. And -4, -6, -10. Wow, how convenient. They're multiples of 5.
So 3 over -2.
Yeah.
Over?
Just 3 on top, -2 on the bottom.
Yeah. It's not a fraction, so.
Yeah, I know. I just how I said it.
Yeah, it's okay. All right, so okay. All right. Yeah, okay. So this is one way, or actually a quicker way to find the coordinate vector, especially if you have 2 by 2. Okay. Are we good?
All good.
Andy.
Indeed. Okay. All right. So what time is it? Okay, I'm gonna skip the proof of this. It's 12:50 right now, so yeah. Yes. Okay.
Can
so
you
I'm
go
gonna-
back and write it later so we can see it in the slides?
Yeah. Okay. So I'll try to prove this for my next class, and I'll save that one. Okay. Okay.
Sounds good.
Yeah. Oh, and then as Hannah pointed this out before, if you're using a computer, you can use the space bar to unmute yourself. Okay. Instead of having to click something every time.
Yeah.
Okay. Okay, it says the following. If V is a vector space, X is an element in V, you have a basis, okay, for the vector space. Then consider a transformation T defined from V to Rn, such as that T of X is the coordinate vector. So T maps X2. So this is in V, this is in R. Is that clear? The T, so what this T does is take, given a vector X in V, it takes the element X in V to its coordinate vector in Rn. Okay. Are we clear what this T does? No?
Yeah, can you repeat it?
Yes. So let's say, here's an example, okay? Let's say V is P2. What is P2? So it's a space of all polynomials of degree less than equals 2, okay? Then if I have, I don't know, 1 plus x squared, that's my x. Then what are the weights here? Let's make it 1, 2, 3, okay? And the weights here are 1, 2, 3, right? So T would take then this function into its coordinate vector, which is 1, 2, 3. Okay, that's just an example. Is it better or what?
Yeah, that's better.
Okay. Then this transformation, what the theorem says is 1-to-1, linear, and onto. Okay. So what was 1-to-1? T is 1-to-1. What was the definition?
Is it that's when there's a pivot in every column, or is it for every row?
Oh yeah, I mean the definition. So the 1-to-1 is basically if U and V are in the domain of T, and if T of U is equal to T of V, then U must be equal to V. We talked about this last time at the beginning of the lecture. Yes?
Yes.
Okay. And T is onto if for every Y in this case, Rn, there exists something, say X, such that T of X is Y. Okay. So please memorize these definitions. And what about linear? When do we say that a transformation is linear? So T is linear if T of U plus V is T of U plus T of V, and T of CU is C times T of U. So I'm sure you've seen this before, correct? Okay, one person, good. Okay, so you'll have to prove this. To prove everything here, this statement, one-to-one linear and onto. So after three, you have to prove these three stuff. Okay. So maybe I'll do it next time in my next class. All right, then let's move on to this isomorphism thing. Okay. So T, suppose T is a map from V to W, and it's a linear transformation. And T is one-to-one and onto. You're given that. Then we say that T is an isomorphism from V to W. Okay. And you may not heard of this term isomorphism or isomorphic, but what comes to your mind? What does your gut say? What is your gut feeling of this? What this word means? Isomorphism, isomorphic. What?
Has one change.
Huh?
It has like one change that it can go through.
One change?
It means they share something.
Good. Like
a subspace.
Subspace?
Or a basis.
Okay. Let's be more specific. Okay? Isomorphism. Okay, so maybe this is not an English word. Maybe that's why.
Greek.
It's Greek.
I'm pretty sure, yeah.
Yeah, I mean, you can say that. You can say that. You probably say that for every word that you don't know, right? Anyway, so here's the thing. Okay, isomorphism means same. So if there's an isomorphism between two spaces, say V and W, that means what? They are the same thing. They share the same structure. It's essentially the same thing. It's just that the way they're written are different. Is that clear? So if a transformation between two spaces that's 120 on 2, they are the same thing. Mm-hmm. Is that clear?
Makes sense.
Okay, so why is that P3 and R4 are isomorphic? Why are they the same? To prove this, you need T, a transformation from P3 to R4, which is 1-to-1 and onto. If you come up with one T between these two spaces that are 1-to-1 and onto, then you're done. That proves that what? The space of all polynomials of degree less than or equals 3 and recurring space R4 are the same thing. So can you guess the transformation T that's 1-to-1 onto between these two? To give you a hint, we just talked about it. We just talked about it here. Given V, a vector space in Rn, which transformation is 1-to-1 linear and onto? Transformation that takes the vector to its coordinate vector. Yes? I mean, we didn't prove it, but if you believe this statement, then that is one transformation that's 1-to-1 onto between these two. So let's use that, okay? So consider T, so P is an element in P3, and then P basis. Okay, so we have to come with a basis. So P3, so let's say if we have 1 plus 2t plus 3t squared plus 4t cubed, then you can consider the basis to be 1t squared t cubed, right? The basis could be like 1t squared t cubed. Okay. Then if I do this, then what is p? Let's call it p. Then what is p? The coordinate vector relative to this basis? It's 1, 2, 3, 4, right? Yeah. So if T is a map that maps a polynomial like this to this vector, then this is 1 to 1 on 2. So it's an isomorphism between these two spaces. T is an isomorphism. Therefore, P3 and R4 are isomorphic, which means they're essentially the same space. Okay. Make some silence if you're confused.
No.
Does that mean you're confused? Not
Not
confused?
confused. We said say something.
Yeah, so say something if you're not confused.
Something.
Does that mean you're confused?
Confused.
I need a second to read over it.
Also fused.
Isomorphic.
What are you eating there, Kang? Banana.
I thought it was a dumpling.
You eating a banana with a fork?
How do you eat banana?
With a fork?
Yeah.
Is it a spoon?
With the chopsticks?
Use a knife. I eat bananas with a spoon. Nothing wrong with that.
Yeah.
It's wild.
Okay, so now this will be probably the last example for today. Look it up. So consider 3 polynomials in P2, and the basis for P2 is simply 1t squared, the standard basis. And let P1 be this, P2 is this function, and P3 is that function, okay? Question is, are these functions linearly independent? Wow, just wow, okay?
No.
Good, that's the answer. Why?
Because you can write P2 in terms of P1 and P3.
Sebastian, is that you?
Yeah.
Gosh.
Is that food good?
Hmm?
Is the food good?
Well. So guys, you may see this or we may not see this. So remember, what did we just talk about between P2 and P2 being isomorphic to what space? This is isomorphic to what? We just talked about it.
R3?
Yeah. So P3 is isomorphic to R4, P2 then is isomorphic to R3. Yeah. Which means, so we have 1 plus 2t squared. This is my P1. Then what is the corresponding element in R3? Using this basis, it'll be P1 beta, which is 102. Hannah?
I was trying to give you.
Is that what you're trying to say?
I missed the 0, but yeah.
Yeah, because there is you can think of it as 1 plus 0t plus 2t squared, okay? Then what about P2, which is 4 plus t? Then the corresponding vector in R3 would be this, which is 415. And the P3 would be, that's the function, 3 plus 2t, which is then the corresponding element in R3, would be this, which is 3, 2, 0. Okay. So so determining whether these three functions are linearly independent would be equivalent to what?
The augmented matrix with those as the left side and the zero vector as the right side has only the trivial solution.
Well, remember, so these are isomorphic, which means they are the same. These are the same space, okay? And to prove that these three functions are linearly independent, it's simply what?
Find a pivot in every row.
Yeah, is to show that these three vectors are linearly independent, okay? Is that clear? That's what it means. These are the same spaces. They're the same space. So if these are linearly independent, then these three should be linearly independent. Okay? And if these are linearly dependent, then same should happen to these three vectors. No, they're not in the same, they are the same space. Okay?
They're isomorphic.
That's what it means by isomorphic. Such a powerful statement. Okay? Because there's a one-to-one onto between every element in those two spaces. Okay? Remember the isomorphism, we defined that to be what? There's an isomorphism, which is a one-to-one onto transformation. Okay? So for each element here, there's a corresponding element there, a unique element there. Okay? And vice versa. Then the only difference between these, for instance, the only difference between this and this would be just the way you write it. It's essentially the same thing. And so you may not know how to prove that these three functions are linearly independent, but you know how to prove that these three vectors are linearly independent. Okay, so all you have to do is now what?
Put in a matrix and so forth.
1, 0, 2, 4, 1, 5. So we have so this class is at what time?
1:10. You got 3 minutes.
Are you guys in a rush to go somewhere?
We have
I'm
another class
sorry,
after
I
this.
forgot you're in
I
quarantine.
have a class after this.
I have Doom Eternal to play, so.
Work.
Some have
So
Animal
luckily,
Crossing.
you don't have to go anywhere to go to the class.
Yeah.
Okay. Wow, I like this actually. So essentially, everyone has at least 10 minutes after this. Okay. So Alex, are you still there?
Yes.
Okay. Could you reduce this for me?
2R1 minus R3 equals R3.
Just give me the row. 0,
0, -3, -6.
Good. And I can make this what? 1 and 2.
0, 0, 0.
Yeah.
Because
so this is 1 and 2. So essentially, this will become 1, 4, 3. 0, 1, 2. 0, 0, 0. Is this good or bad?
Bad.
Depending on what you want, but yeah. This means what? The three vectors are not linearly independent. Yes? Because essentially we can write this vector in terms of these two. So we just proved that the three vectors are not linearly independent, which means the corresponding functions in P2 are not linearly independent.
So they're linearly dependent.
Yeah, same thing, yeah.
Does that mean they're not isomorphic? Or they're still isomorphic?
No, these are still isomorphic. They are the same space. That's what allows us to show dependency using these three vectors, okay, because they are the same space.
Got it.
Okay. Was this too much?
Right on the money.
No.
Okay. I mean, it's not. Like, I'm gonna be honest. It's not something that's like obvious, but if you think about it, it kind of makes sense. Think hard about it.
I don't see how I'm gonna use this in my life.
What?
I mean, maybe.
Okay, computer science. Okay, remember that.
It also helps you solve systems of equations for physics.
Okay. I mean, how'd you program a computer to see if these are linearly independent functions? You just do something like this, okay? And the theory behind that is because these are P2 and R3 are isomorphic spaces. Okay. If someone's not happy, Noah.
What's up?
No, are you Noah Franklin?
No.
Who's Noah Franklin?
No, he's the brother from Scarlett Johansson.
Me.
Okay. Yeah, nobody signed up for online classes, okay? But yeah, it just ended up happening this way. So you can be angry about it, or yeah.
If you guys didn't know, KSU is also issuing a $234 refund for things like gym access and stuff like that.
Oh yeah, I saw that. I like that.
Oh really?
Yeah, I'm getting money back.
What about parking?
Yep.
Yeah, I'm also getting parking back.
That should be included with it too. Also, I hope they give us some sort of tuition give back because online classes are so much cheaper than in-person classes. Like I have a friend who takes cybersecurity as an online degree, and he pays a lot less than I do for in-person.
Because this doesn't give me the full experience of being there.
Yeah, that's good because I'm not getting paid more to do this, and this is more work for me actually, because it's more bang for your buck, I guess.
I wonder how summer classes will go.
They won't.
Most likely online.
I'm taking an electrical class. I don't want that.
You don't want, yeah, I mean, how do you learn electricity online? Don't you have to touch it?
No, you
I'll
can do
be sad.
simulations.
OT Spice is going to be a paid.
Which is good, because no pain, no gain.
No pain, no gain.
It's digital logic, though. It's not even circuits anymore.
Oh, you're taking digital logic?
Yeah, man.
Taking that right now. It's not too bad.
Okay. But online.
Yeah.
Logic ICs are pretty cheap.
They're probably gonna make you do the lab at home.
Nah, I have Duvall. He'll figure something out.
Oh, you have Duval? Oh. Also, if you need one of the kits, I have one. I'm gonna use it after this, so I can sell it to you.
Thank you.
All right, so it just so happens that as we are learning this more complex concepts, we're doing this thing online, so it's kind of like a double whammy for you guys. But so make sure that you study, review this concept before next time, okay? Because we don't want to fall behind.
Okay.
From now on.
Do we have a quiz on Monday or something?
Yeah, I told you there will be quiz every month, like every lecture period. Okay. Not just for the concepts, but then to get ready for the online
yeah, for practice and so on.
To get you guys familiarized with the platform. Okay, so for those who haven't taken the online quiz 00 yet, please do it and let me know if you have any questions. So you might have some trouble accessing the webcam because I completely explained that you need to turn off some programs. Okay. So you need to pretty much turn off everything. Anything that uses text messaging or webcam, turn off those apps, and then try again. Yeah, it should be fine. Okay, any other questions, guys?
No.
Are you excited
No.
for the upcoming weekend?
No.
Yeah.
More.
I have to move out of my apartment.
Oh, more quarantine.
This quarantine sucks.
No, since
I'm going in.
there's no point like living next to the campus if there's no class on campus, so I'm going back.
Oh yeah. Okay, so make sure that you have access to the internet. I mean, obviously. All right, guys, and thanks for showing up today.
Bye, Charles. Have a good day, man.
Hi, man. Stay safe.
Kong.
I finished all of it. So yeah, okay.
The strawberries too.
Bye, guys.
Bye.